Alright, I think we're on the air. Cool. Except I need focus. Alright, how is everyone? Hey Nick, do you have a GDB tutorial video? I was trying to debug my PA1 last night. Yes, I do. It should be, let's see. Let me hop on to the video list. Quick intro to GDB, so you can find it on the video list on the Linux server. And in my years of making various like artsy videos and pouring my soul out and all this stuff, this is the video that's gotten the most views. It's like 180,000 hits. So I guess it says something worthwhile. And that'll give you a quick run through of basic commands, and I use a C program as the target environment. So so yeah, have a look at that if you like. And I want to make some comments this morning about the assignment in general and how to proceed with it, and some things to make sure you check to get the most points possible. So any other questions first? Happy Friday, everybody, definitely. Feels like it's been a long week. I don't know what's up with that. And remember, Monday is a holiday, so no class on Monday. So we get a long weekend, perhaps. I have not graded most of the SLPs yet, but I will read those over on the weekend along with grading PA1 and give you a grade and give you feedback if I feel like you need to you know, add something or update something and so on. Yeah, Monday holiday, it's good. All right, so let's see. Let's call this GIT Habits, Habitas. So I did a trial download of your Git repositories this morning, and about a third of the class has created a repo on GitLab and added me as a reporter, which means 2/3 haven't. And I'm going to repeat what I said in 224, right? The day you get an assignment, that's a really good day to go ahead and set up a Git repository. Do a git init, make a README file, add it, commit it, do a git remote add origin to GitLab, push your code over, hop onto the website, make me a reporter. If you've done that, you know, multiple times, that takes less than 5 minutes to do. And you can do it, you know, the day that the assignment is given. And what does this do for you? Well, now, as you're developing your code, anytime you make a change, git add, git commit, git push. 3 commands, you can put them in a script, and all your changes get pushed out, you know. You can schedule it if you want, have something that wakes up, you know, every 4 hours and does a git add, git commit, git push. But it you know, gets you in the habit of using Git, which is important. It keeps, you know, your latest code over on the repository. If you switch to a different system, you can pull down your code from there and work on it. If you're developing at home and your hard drive dies, you have a backup. If you make some strange changes and you want to go back to an old version, you've got the full history of all your changes over there on GitLab. And most important, grade-wise, right, if something happens and, you know, you lose power or you lose internet or you pass out and you don't, you know, have a chance to submit your code by the deadline, your latest version is already there. And I've got something to grade, and maybe, you know, it's missing, you know, some last detail or something, but it's over there. It's a win-win-win-win-win situation, right? There's no downside to it. Other than, you know, take 5 minutes when you first get the assignment and set this up, and then git add, git commit, git push. And like I say, you can make that you know, a 1-character command. You can make a command G, and you know, as you're editing, just before you log out, just hit G, hit enter, and push that over. Let's see. Work with your script since I initially in my repo PA1. You do not need a README. You don't need a README. It's you know, almost always standard to put a readme.md in your Git repository, and you know, the Git websites will generally show that on the main page when you go to the project. So you know, it's not mandatory, but it's a good habit. So that's my comments on Git. All right, so let's do. Let's do the PA1 sample program again. So we did this when we first talked about PA1. I showed you sample code. Yeah, the repo needs to be called linked list 1. Exactly. If you named it something else and you try to rename it, it's probably not actually renamed in a way that will download when I try to download linked list 1. So a good recommendation is, after you've got your repo and you think you're all set, go to a totally new directory, right, that's never been placed under Git, and say git clone git at GitLab, right? Pull down the repository from GitLab, and it should create a subdirectory under your current directory named linked list 1. And make sure that works, right? That's kind of the acid test. And I'll show you what I'm going to do. So Saturday at noon, I basically say git clone linked list 1. And it's, you know, it's just a bash script that figures out, you know, who all the users are in the class, and so on. And for each of them, it basically does a git clone, git at gitlab.com, colon, your user ID, / whatever name I type in, which will be linked list 1.git. So you can run this command yourself from a directory. It's cleanest, just make a new directory, go in there, run this command, and it should create a subdirectory named linked list 1. All right. So what do? You go into that, you do the git clone, you make sure it pulls down the repository, you go into that directory, you say make, and it should compile all of your programs, right? If you've already got things in there, say make clean and then say make, and then run your program and do a few tests, right? And you're mimicking the exact thing that I'm going to do when I get to grading your program. Right? And if none of that works, if it doesn't find the repository, if it doesn't find the make file, if it gives compile errors when you say make, right, that's going to be what I experience too. And so you know right up front that you've got to change something. The only thing this will not check is, did you add me as a reporter, right? And so, you know, day one, when you get an assignment and you push over your initial repository, add me as a reporter, you can send me an email and say, hey, I made a repo, can you see if you can download it? And I'll go ahead and I'll do this command, you know, day one, and I'll send you a note and say yes or no. And if that works, then you don't have to worry about it, right? So don't let Git be a hindrance to you. In fact, let it be, you know, something that makes your life easier. All right, so let's see. Let me add some notes here. All right, so sample program. So I just call this main. All right, so you run your program. Here's what it does. It gives you a prompt. The first time that you know, when you first start this program, if it prints out a short help message, I'm okay with that. But that's just once in the very beginning. After that, just print a prompt. If I say P, print the list. If I say, you know, search for some number, tell me it's not found. If I insert a number and then I search for the number, it's found. If I say P, it prints out the list. If I insert a number twice, node already in the list. If I try to delete a node, success. If I try to delete it again, node not found. All right. So what's important here? I've had a number of people come in and show me their code. Almost nobody is following this, right? This is part of the specification. Single greater than sign followed by a space. That's your prompt. Not enter a command. Not here's the commands. You can use greater than space and wait for the person to type something. These commands that take two pieces, they come up on one line. It's not S followed by enter followed by the number you want to search for followed by enter. It's a single line. Okay. Hey, just like your program, but without seg faults. Well, I haven't seg faulted yet, but I could. All right. So single line commands. If you have multiple things and you say print, they all come out on one line, right, with a new line at the end. So those kinds of things, right? And no extra output. No, right? It's basically one line of output in response to each command. And I want this partially so that, one, my experience as the user in interacting with, 40 or 50 programs is consistent. So I don't have to relearn, 40 or 50 different interfaces to test your code. That's the first reason. The second reason is, I can see the last, 10 commands that I've typed all on one screen. And if you're clearing the screen and if you're printing out this kind of synopsis in between each command, then I have to do a lot of scrolling back and so on and so forth. This is my help command. If I type anything that's illegal, if I type something without a number, right, or if I type a question mark, or if I just hit the enter key, right, anything that's not a legal command, there's my synopsis. And I'm not picky about what this looks like because I'm asking for help, basically. All right, so I want a uniform experience for the user. I want to be able to see, my last several commands on one screen. The other thing is, right, as you move on to more and more programming courses and you're at a university and you're turning in assignments, the level of dogma kind of tends to go up, and people are going to get more and more picky about following the assignment prompt specifically. You'll find people running your code through automatic graders. I don't do that with programming assignments, but other people will. Or, you're on the job and you're asked to create a piece of code that's going to interface with some other piece of code. And maybe that other code is going to look for the word success or node not found whenever you delete. And if you output, success in lowercase, your code's not going to work with that other piece of code, right? So I want to put the bar really high as far as make sure that, here's the specification for the program, make sure you can follow that, right? So yeah, what someone just said in chat. All right, so that's kind of final test, right? Hopefully, the most challenging part of this is the linked list part itself. This is, a combination of being able to read the spec and follow it, and doing 224 stuff, right? Which I'm going to review shortly. Some ideas on doing the input and the parsing and so on and so forth. All right, but does this make sense, what we're looking for? All right, cool. So let's talk about doing input. And so I'm going to suggest what I've mentioned to some other people. On Canvas for these courses, I've got a additional C book with exercises. I wrote this book specifically for CSE222. I wrote it to be kind of a bridge between 224 and 222 for people who passed 224 but are still kind of fuzzy on some of the concepts, or maybe, you know, nailed the later part of the course but missed the parts where we talked about input, right? Or for you know, moving on to more advanced C programming, some of the things that are touched on in 121, 224, but maybe not necessarily covered. The first like 5 pages of this book tell you pretty much everything you need to know about using FGETs and scanf. It talks about the motivation for those and things like that. So you know, it's a free download. If you're rusty on input parsing and stuff, you can go back to the videos from 224. But take a look at this. You know, why we don't use scanf, right? The problems you can get into with that. Why it works better to use scanf, right? So here's a simple example. And then some sample code, right, of basically using scanf to parse something like, you know, input that has an integer in the beginning of it. And so I talk about parsing input. And so, for example, here we're trying to input, you know, the word speed followed by an integer. And there's typos in this book. I just found another typo. But that's okay. So take a look at that. It's on Amazon, so it's published, right? But it's a free download. I think it's like $4 at Amazon, which it's whatever the cost is of the printing. If you want a hardbound copy, I wanted that option up there. But it's a small, you know, 100 pages. So download the PDF. So let's look at parsing. In particular with respect to PA1. This is not the way that you have to do this, okay? But if you're kind of stuck, if you're bouncing between different ideas for PA1 processing input and so on, here's a way to do it, right? So what are our command options? I followed by a number, D followed by a number, S followed by a number, P, X, and anything else. That's really all your program responds to, right? And there's, you know, 3 commands which are a letter followed by an integer, and there's 2 commands which are just a letter. All right, here's an easy way to do parsing, right? Break it into pieces, right? First figure out what kind of command this might be. Is it an insert? Is it a delete? Is it a print, right? And you can do that by just looking at the first letter. So you could do, you know, you know, let's input our users typing into a string variable called command. Make this big, you know, 100 characters or something. So we can say if command 0, and for a character we can use double equals. For strings we can't. But for a character, we can use double equals. So if command 0 equals single quote I, well, we know that the person's trying to input something. So do that processing. If command bracket 0 equals a D, well, the user's trying to delete something, so do that processing, right? So you can write 5 of these statements, and in each of these sections of code, process an insert, process a delete, process a search, a print, or an exit, and so on. Now, if the user typed, you know, a P, well, you know, that's pretty easy. Just call your print method with the linked list array as an argument. And, you know, I would do this in inside a loop or something, right? So if this is inside a loop, you could say continue to go to the back top of the loop. If it's inside a function that you called, you could say return, right? Or you can make these a bunch of else's. And then, you know, if the command starts with a P, you'll do what's in this print section, and you won't do any of the other if statements, right? So you've got options. And if you do it with a bunch of else statements, right, or if you kick out of each of these by saying continue or return, then at the very end, you know that the person typed something that's not recognized, so you can call your help function to print out, you know, the help message. So this is your first order parsing, right, to figure out what kind of command did the person type in. And for commands like, you know, P, which just prints the list, you just call your print function. For X, which just exits, you could just return if you're in the main program. For these other commands that need a number, we need to do some additional processing. So if the person said I, well, now we need to know, did they say I followed by a number, and if so, what is that number? So now we want to use our scanf. So we can do something like if one, so this is an insert command. If one equals string scan command I%d, save the result in a number. Then I forget if it's called add or insert. Right? So you know the command starts with an I, so the only possibility is they typed in an I followed by a legal integer. That's the only legal command at this point. So use scanf to do that heavier work, right? Search for an I followed by an integer, save the converted integer into num, and look at the return value. If it comes back with exactly 1, you know that you've got a good value in num. If there's an error, it might come back with 0, it might come back with -1, right? Check to see if it's equal to 1. If it's equal to 1, it's a good number. Go ahead and add it. Otherwise, give them help. Right? So if you break it into pieces like this, it can be a lot of code, but it shouldn't be very mysterious. It shouldn't be very overwhelming, right? And yeah, this works perfectly with a switch. Switches work great with characters. So you could switch on command bracket 0, and now you can do, you know, case I, case D, case X, and so on. And after each of those, you can say break, which takes you out of the case statement. And that's you know, my preferred way to do parsing of things with this syntax. It's pretty straightforward. You can go directly after these with scanf, right, and look for an I followed by a number. But you can't really use scanf very reasonably to pick up a P or an X. You can try to scan it with a %s and save it somewhere, but you're really doing a lot of extra work that doesn't buy you anything, right? Ultimately, you just want to know, did they type in a P? You can try to do this with string compare, but that's a little bit wonky because, you know, fget puts a new line at the end. So you'd need to deal with that, and then you could string compare command to P. But what you cannot do right? That's not going to work. You can't compare strings in C by using equal equal. Because this is a pointer, and they're pointing to different things. They might both point to something that contains the letter P, but they're pointing to different things. The values of these two things are different. Yeah, which you generally find out the hard way. You could do string compare. Right? But remember, if you do an fgets, there's a new line at the end. And don't do this. This is really just comparing character for character, and if all you care about is the first character, right, just do if that first character is equal to the letter P. So yeah, single quotes are your friend. And it's best to avoid ASCII codes. Like, you could put in the ASCII code for a lowercase p, but single quote p is synonymous with that ASCII code, and then it works on you know, alien galaxies where they don't use ASCII. So that's a bonus. Yeah, this is easier in Bash, but linked lists in Bash would be kind of trippy to try to write. You could do this version of linked list in Bash actually, because we can do arrays. I've never done that. That would be an interesting assignment. Um, all right. Let's see. Cool. All right. Let me make another comment, which may be, you know, a little too late for this time around, but I'm pretty sure I alluded to this at least early on. Hopefully, you're testing your code as you develop it, right? So hopefully, as you're writing your PA1 or whatever, right? You're testing the code along the way, and you don't need a working main program to test your code, right? You can write a main program. We've done this, in fact. You can write a main program that says initialize, and then add a 5, and add a 2, and add a 20, and then print, and just makes calls to your linked list code. And as you develop your linked list code, you can add to that testbed main program more calls, right? And you can add more test cases. It's like, oh, so and so had a bug with an empty list. Let me try that, right? So start with an empty list, call print, call search, call delete. Add a node, call search, call print, call delete. Delete a node that's already been deleted. Search for a node that's not in the list. Search for a node that's been deleted. Insert a node twice. Delete a node that you've tried to insert twice. And then try to search for it, right? And write out a test plan on paper and then write code to do it. And now every time that you make a change, just say make, enter, main, enter, and, it says good or bad, whether you passed all your tests or not. And that makes your development cycle a lot quicker and a lot easier. And you don't have to think about, now I'm in testing mode, so you put on your QA hat and you start doing your tests. And now you go back into coding mode, so you put on your QA hat, your coding hat. If you've got this test bed that every time you change your code, you can just run it and make sure it works, that's cool. And then your main program is kind of a separate thing. But you've already, finished your linked list code. All of those things work. Now you're working on the interface. So you put on your 224 cap and do your fgets and scanf and so on. Yeah, starting with print is definitely helpful because you can use that to see what's going on. If you don't like going in GDB and looking at memory dumps, you can just keep printing out your linked list. As long as print works, it's a good debugging tool. Speaking of GDB, we need to talk about the GDB quiz one of these days. That's another day. All right. So any questions about that or about PA1 or anything else other than alien galaxy coding? Can we go over some of the tests you will do on our programs? I don't have a fixed test plan, but what will I do? Good things to test. So I'll start off. I'll try to print an empty list. I'll search for something. I'll try to delete something while the list is totally empty because I just started the program. And then I'll insert one number, and I'll print, and I'll search for that number, and I'll search for a different number. And I'll try to delete a number that doesn't exist, and I'll search for a number that doesn't exist. And then I'll delete that one number, and I'll print, and I'll search for it, and I'll try to delete it again. And then I'll insert it again, and I'll print, and I'll search for it. And then I'll insert a second number, and I'll do those same tests. I get in a really weird mode when I do this. It's like people look at me and they just kind of walk away. because I'll just do this for hours, you know, like 40, 50 times. And so then I'll insert, you know, 5 or 6 things in some weird order, and I'll make sure they come out sorted. And then I'll start searching for things, and I'll search for something in the middle, at the very beginning, and at the very end, and I'll search for something that's not in the list at all. And then I'll try to delete the first thing, I'll try to delete the last thing, and I'll try to delete something from the middle. And I'll do that with, you know, 5 or 6 things in the list, so that the list doesn't become smaller than 3 during that. And I'll print during each of those. And then I'll try to delete everything in the list, get it back down to an empty list. Do a print, do a search, do a delete, make sure it's still behaving. I'll try some syntax things, so I'll do an I without anything after it and make sure I get an error. Or I'll do a D with nothing after it and make sure I get an error. You know, I'll type some gibberish and make sure I get a help message, and then I'll do an X to exit. And then I'll go ahead and I'll look at your code, and I'll make sure there's comments. I'll make sure that you've got a comment block in the beginning of main, and that you've got comments in front of each function. And then as I'm doing this, right, I'll be going through that rubric and making notes about where any deductions might be, and then when I'm done with all of that for everybody, I run those notes through a program that turns them into comments that get posted in Canvas and calculates the final grade. So let's see. And I will stick pretty closely to this grading rubric. The heck is that? That's homework 1. So I'll stick pretty closely to this, right? Oh yeah, and I'll say make when I first get your project. I'll look and make sure there's nothing in there except source code. If there is, I'll do a make clean, and then I'll say make, and then I'll say make again and make sure it doesn't do any work, and then I'll probably touch one of your .c files and say make and make sure it just compiles that .c file, and then I'll eyeball the make file itself and see what it looks like. And you know, if it passes all my tests, then your get node, release node, print, init, and all that stuff automatically must be working, right? But I'll still look at the code and make sure you didn't, you know, write a program that sends a text message to someone on a desert island and asks them to add something to a list, and they, you know, mark it off on their Bamboo and send you back the new contents. So I'll make sure it's actually doing linked list code. And that's pretty much it. It is Philosophy Friday. The desert message would be more impressive, to be honest. I would probably, you know, suggest that you turn that into your SLP or something. Especially if you bundled it in all of the system calls that are normally done. In fact, you could re-implement Linux and just rewire all of the lowest level system calls to send text messages to different people whose job is to, you know, retrieve a byte from a file or something like that. That would be cool. Crowdsourced Linux. I'd like that. Or smoke signals. Yeah, good SLP. Someday for my 101 class, I'm going to do a human computer. I've always wanted to do this, and 101 is the perfect forum for it. So, you know, assign each person a job as a gate, and give them flashlights. And basically, when you see a flashlight coming from this direction, you know, turn your flashlight off. Or if you see 2 flashlights coming at you, turn your flashlight on. Otherwise, turn it off. And see if we can build a light-based human computer that, you know, makes a counter or something. All right. Any other questions? All right, PA2 is going to be PA1, but we're going to build it on top of pointers. And so let's start talking about pointers and such. So a linked list is a genuine bona fide data structure. It's possibly the most popular data structure, that or a binary tree, but you know, linked lists are very useful in general. So we're going to code a linked list that's actually going to use dynamic memory. So the whole idea of PA1 was built around this notion of an array of struct nodes, right? We basically allocated space for 100 struct nodes. I'm just going to call them nodes. We allocated space for 100 nodes by telling the compiler, you know, linked list is an array of 100 elements. And then as we implemented our linked list, every time we needed a new node, we simply took one of those spots we'd allocated in this array. And we had a bit we could set called valid to say this block is in use, this node has been allocated. And when we are done with a node, because we've deleted it from the list, we've changed the pointer so that node's no longer being referenced, we clear that bit to say, hey, this block, this node is available for use, right? So we're basically doing our own memory management. And our memory is just this block of 100 nodes that we've pre-allocated. And we take things from that and we return things to that memory pool, and then we use those. So PA2 is going to be exactly the same with one difference. Instead of taking our nodes from this array, we're going to take them from the main memory of the system. So instead of calling getNode, you're going to call malloc. Instead of saying release node, you're going to call free. And instead of saying, you know, linked list bracket index dot field, we're going to have a variable that takes the place of linked list bracket index, and will basically be a pointer to a node. I don't want you to do this, but I've had people do this just to see if they could do it. You can turn PA1 into PA2 just by doing global substitutions in VI, and it's not that many global substitutions, right? You can write some regular expressions that will turn PA1 into PA2, because the structure of PA2 perfectly parallels PA1, right? But don't do that for your first pass. I want you to actually write PA2. You can reuse your main program, because that's just making calls. And if you stuck to this idea of the linked list as an abstract data type, you might need to make one change to your main program, and that's it, right? Your initialization is going to be different because you're not going to allocate an array of nodes. But PA1 main program will mostly work exactly the same for PA2. And your add and search and delete and print functions will be almost exactly the same. You'll have to change how you reference the things in a node, but other than that, they're going to be exactly the same. And then, like I say, free is going to be replacing release node, and malloc will replace get node, and that's it. So PA1 is hopefully getting us used to linked lists, thinking about, you know, these boxes pointing to other boxes, moving down a linked list, keeping track of the previous node, making changes to the pointers. That's the goal of PA1. And then PA2, we already know how to do that stuff to some degree, so we use the mechanics of dynamic memory to make an actual genuine bona fide linked list. All right, so and we'll talk about PA2 next week. I'm not posting it yet because I don't think I'm going to make it due until 2 weeks from today, so, or something around that. Whoa, someone was getting errors from standard IO and standard lib. Were you including them in your .h file maybe? Because if you did that and you also included them outside, it could get a little weird, although restarting your computer doesn't seem like it should change that. Or rebooting 3 times. Yeah, you shouldn't get errors from standard I/O. All right, so we're going to have to jump deeply into the concept of pointers. And so pointers are really just references to locations in memory. Now, everything we do, every variable we use is stored in memory, right? We have CPU, we have a memory. When we say integer I refers to somewhere in memory. And we don't really have to think about that if we're just using a variable. But sometimes we want to actually look at things at a particular location in memory, other than a location that, you know, corresponds to some variable like I or you know, counter or something like that. So the mechanics are like this. Integer I tells the compiler, when I say I want an integer. And the compiler will work with the linker, and in the memory of your computer, it will find some spot where there's 4 bytes to correspond to the variable I. And this will be stored somewhere in memory. Like 7FFFFE3H. And that location in your memory, that's where I is stored. So if you went to your DRAM, right, somewhere in that 16, you know, billion bytes, somewhere there's 32 bits corresponding to this integer. And there's a tag we can use to get to that. It's called a memory address. Now this is a virtual memory address, so it gets translated into a physical address, but ultimately something in the memory management system takes this and figures out, oh, these 32 bits are the variable I, and sends those to the CPU. Alright, so if we use this symbol in a C program, that means I want the address of I. And in this case, that would be equal to 7FFF-FE3H. And it's normally not something we care about, right? We don't usually care where this variable is stored. But if we do, we can use an ampersand in front of a variable name to see what's at that address. So if I say something like, you know, P equals address I, that'll set P equal to something, looks like a big integer, but it's actually a location in memory. Now if I say star followed by a variable, right, if I just say a variable, it says tell me the value of that variable. If I say star followed by a variable, this is the thing pointed to by this variable P. So suppose I was equal to 2000. If I were to print ampersand I would get 7FFF-FE3H. If I were to print star I, well, the system's going to go to memory location 2000, and whatever is stored there, that's what it's going to print. So star lets us basically do an indirect reference. It says, hey, I'm not interested in I, I'm interested in the thing that I is pointing to. So find the value of I, but don't stop there. Find the value and treat that as a memory location. Tell me what's at that memory location. Alright, and you can play with this. You can play with it in C code, you can play with it in GDB. So yeah, CSE222A, this is also Engineering 270. This is the indirect file reference from 270. So load file, select register, and INDF0. That's what this is. Alright, So we're just about out of time, and there's no class on Monday. So dust off your brains about pointers and stuff. That book that I mentioned also has a chapter on pointers that basically goes through this from the beginning, and so that can be worth glancing at. I mean, these chapters are like 5 or 10 pages each, so so they're a pretty quick read, hopefully. But dust off your memories about this. And Tuesday, what we're going to start doing is looking at how we use pointers and addresses of variables to rewrite our linked list code, building up structures out of memory on the fly as the program runs. All right. That's us for now. So I will see you next time. If you're not in 215, have a great weekend, and I will see you on Tuesday.